Hello, hello, hello. So today we are going to be finding how many real and imaginary roots each of these lovely polynomials have that I have below, which this is actually an activity that we're going to do in class together. But the first three on here, so 1, 2, and 3, do need to go in your handy dandy notebook. So even though it is an exploratory activity, we will be writing these in our handy dandy notebook. Now, okay, we are doing this in class, so if we haven't done it in class yet, I probably would not be watching it so you don't, mess up everything we do in class and know all the answers before class time, because that just ruins all the fun. But if you missed class, this is a good opportunity to learn what we did miss in class. So follow along. All right, so what we're going to do, we're going to be factoring the polynomial using those nifty techniques we talked about, which we will be referencing this awesome factoring chart to know which factoring technique to use. And then after that, we will be finding the zeros, which in the Prezi, we talked about how to find zeros from factored form using the zero product property. You're going to have a parenthesis times a parenthesis, and if two things multiply together have to equal 0, because we're trying to find zeros, which that's when your y is equal to 0. Okay, so that means one of the parentheses has to be 0, because anything times 0 gives you 0. Holy hot dog. Okay, so after we factor this thing, we will set each parenthesis equal to 0 to solve for lovely zeros, or x-intercepts, or roots. All three of those mean the same thing. Okay, so if you ever hear zeros, x-intercepts, or roots, they mean the same thing. Okay? Alright, so first of all, the first thing we always do when we factor, if you see here, GCF first. Okay, no matter what, let's always try to look for a GCF because that always reduces our polynomial down, which helps us when we're solving. Okay, so I'm looking at this right here, f of x equals x to the third plus 25x. This will be example 1 in your handy dandy notebook. Okay, so I'm looking for things in common between each of these terms. Okay, so the numbers in here, this one doesn't have a number, which means there's secretly a 1 in front of that x to the third. Okay, but 1 and 25, the only thing that goes into both of those is just 1, and that's never really a GCF, okay? So let's look at our variables. I got an x to the third and an x. Okay, so if I'm trying to grab the same amount of x's from each term, and I want to grab the same amount of x's, okay, so the largest amount and the same amount of x's, all I can grab is 1, because this one only has 1 to grab, but this one has 3. So the most I can grab from each term is 1x. And remember, you guys, the quick way or the shortcut to know, you always take the smaller exponent when you find the GCF. So since this one doesn't have 1, there's secretly a 1 as the exponent. Okay, so x is going to be my GCF. Yay! So we're going to start with our GCF, which is an x. Okay, so I'm going to factor out that bad boy and write what I get over here. Okay? Okay, so remember, we're going to divide each part by our GCF, which is x. So I'm going to divide the x to the third by x and the 25x by x. Alright guys, when you're dividing two variables with exponents, you subtract them. And remember, these secretly have a 1 as the exponent. So 3 minus 1 gives me x squared. So this will be x squared. And then 25, well 25 doesn't have anything to divide by, okay, so I'm just going to have a 25, and then my x will cancel out and turn to 1. So all I'm left with is a positive 25, you guys. So x squared plus 25. Okay, so now, since I have a number times a number, okay, we're starting to get in factored form. Okay, so after we pull out the GCF, we look at our parenthesis to see if we could keep factoring. Remember, we're always trying to continuously factor until we cannot factor anymore. It's going to be awesome. All right, so I have two terms that I'm adding. Okay, so if I look at my nifty chart, okay, the one that has two terms, these are over here. These are our factoring techniques. Okay, I have two terms, and if you see here, I'm adding. I got an x squared plus 25. So I'm looking for a sum, which the only sum one I have is a sum of two cubes. Okay, so that means I need two perfect cubes added together to allow me to use this technique. So I need, basically, I have to be able to cube root each of these to use a sum of cubes. So let's see what happens. Okay, I got an x squared, which I can't cube root that because there aren't three of the same number that I can multiply together to get x squared. And same with 25. The only thing that goes in 25 is 5 and 5. Okay, now we can square root each of these, but be careful. If you see here, there's no such thing as a sum of squares. We got a difference of squares, okay, but we don't have a sum of squares. So we cannot use any of the factoring techniques. Okay, so there are several options we can do. Since we have a quadratic, so my highest exponent's 2, we could use the quadratic formula. Okay, and our missing term, I have my x squared term and my number without the x. So the term that's missing is b. Okay, so secretly, I'm just going to write it over here. We have x squared plus 0x, since my b term's missing, technically a 0 is there, and then plus 25. So if you want to do the quadratic formula, you can, using your a as a 1, because that's secretly in front of the x squared. Your b could be the 0, and your c could be the 25. Okay, so you could do the quadratic formula on it. Okay, now, I know a faster way though. Okay, because there's nothing wrong with using the quadratic formula, but sometimes that takes a lot longer than we need to do on a problem. Now, I'm going to teach you a technique that you can only use on quadratics, and you can only use if you have a binomial. So a quadratic binomial. So a quadratic, and there's two terms added together. Binomial means two terms. So the technique I'm going to show you, you can only use if it's a quadratic binomial. Nothing else. If it's anything above a quadratic, so a cubic or a quartic, you cannot do this. You cannot. Okay? So, to solve for the zeros on this one, or basically define the zeros, okay, we're going to have x squared plus 25, and I'm just going to go ahead and set that equal to 0. Okay? So guys, I can already set each factor equal to 0, so we might as well find all the zeros. So currently, this is factored form. We cannot factor it anymore. None of our factoring techniques worked. Okay, so since I cannot factor anymore, this is factored form. Okay, so factored form is donezo. I can't factor it anymore. Factored form is done. So this is factored form. Okay, but to find the zeros, I'm going to set each of these bad boys equal to 0. Okay, so my first term is the x. I'm going to set x equal to 0. Okay, which that one's already solved for you guys. That one right there, x equals 0. So that one's done. Now the other one I have to find is this one. So I'm going to set x squared plus 25 equal to 0. And I'm going to do it over here so to make sure I have enough space. Okay. Alright, so let's get going. So, we gotta set this equal to 0 and solve. And again, you can only do this if this one right here is a quadratic binomial. Okay, if it's a quadratic binomial, you can go ahead and set it equal to 0 and solve, which is pretty awesome in my opinion. Okay, so let's solve this thing for x. I'm going to bring my 25 to the other side. So I'm going to subtract 25 on both sides. So minus 25 and minus 25. Okay, 25 minus 25 cancels out and turns to 0. Okay, so I'm left with x squared equals 0 minus 25 is negative 25. Alright guys, we're really close to solving for 0, but I have to undo the square, which the way we undo a square is by square rooting that thing on both sides. Okay, so the squared will cancel out this, or the square root will cancel out the squared. So I'm left with x equals, don't forget whenever you square root both sides, there's a plus or minus. Alright, now let's talk about this right here. First of all, I cannot have a negative under my square root. Not allowed. Okay, so remember to make that negative go away, an I is going to pop out. Okay, so this is equal to plus or minus I root 25. Okay, and then finally, we know what the square root of 25 is. Square root of 25 is 5. So finally, which I'm going to write this up here so I don't invade on this space anymore. My final answer would be x equals plus or minus the square root of 25. What times what gets me 25? Holy hot dog, you guys are so smart. It is 5. So this will be plus or minus 5i. Okay, which typically, you guys, we write the number before the I. It's not wrong to say plus or minus I5. It just usually isn't written that way. Alright, so here are my other two zeros. Okay, so I have 1 0 here and 2 zeros here. So I have a total of 3 zeros. Okay, so I'm just going to write that here. I have a total of 3 zeros. How many real zeros do we have? So, real zeros. Basically, you guys, a real zero doesn't have an I. An imaginary zero has an I. Okay, so this one has to have an I in it. This one has no I. So no I and I. Okay? So the ones without the I is this one. So I have one real 0. Okay, and the number of imaginary zeros I have are 2. So I have 2 imaginary because one of them's a plus and one of them's a minus. Okay, so one of them's like positive 5i. I could write like this, x equals 5i or x equals negative 5i. So there are 2 imaginary roots. Yay! Okay, so I have a total of 3 zeros. One of them's real, one of them's imaginary. And the degree of the polynomial. To get the degree of the polynomial, you go back to the original and you state the highest exponent. So my highest exponent is 3. Okay, because this one's 1 and that's a 3. Okay, so the degree is 3. And remember, you guys, we talked about this before. Okay, the amount of total zeros should equal the degree. So holy hot dog, I have the same amount of zeros as my degree. So we ended up doing a great job, you guys. Awesome.